Hello guys, welcome to another J for JavaScript tutorial, and today we'll be talking about operators in JavaScript. In the previous videos, we looked at how we use arithmetic operators on numbers and how they work with strings and so on and so forth. So I recommend you go watch that first before we continue with this. So anyway, in this brief tutorial, we'll look at operators and some of the different operators we use in JavaScript. For example, the type operators, arithmetic, comparison. We look at the comparison operators like the equal to, not equal, greater than, greater, ternary operator, logic operators, and finally some bitwise operators. So buckle up and let's get started. So as I said in the previous video, we looked at various types of operators like arithmetic operators, string operators. This is when we're trying to concatenate strings together. Assignment operators, as we saw, the compound assignment with the plus equals, slash, backslash equals, and etc. etc. Type operators, as we looked at in the first videos, returns the data type value of an operand or the value passed within the function. So all these are in the previous videos if you have been following. Let us start with something rather interesting, and that is the operator associativity and precedence. And yes, I use DuckDuckGo as my search engine. You should give it a try. So this article, or this wonderful outlined article or from the Mozilla MDN web docs, gives you a clear example what the precedence and associativity means. So what that means simply is operators with a high precedence number are passed first in the JavaScript engine than the others. So as we can see, our brackets here have a higher precedence number, meaning they will be passed first or recognized first when your code is compiling. Associativity just simply means the direction from how it flows from left to right or right to left. So I'll leave a link to this article, this web page for you to go through and see more precedence levels and their associativity. Let's let's start with the numbers. So let's write a simple variable here. So what do you think the answer will be in the console? Well, if you've done some maths, of course, we know that multiplication has a higher precedence than addition, as we can see here. Multiplication has a precedence of 15 and addition has a precedence of 14. So when your expression is being passed by the JavaScript engine, it's going to multiply first, then add the number. So in that way, our answer in the console will be 7, as you can see. So if you want us to add first and then multiply, we use the brackets, which we saw in the document has a higher precedence than multiplication. So in that case, our answer in the console is 8. Great. Great. Let's look at equality. So condition operators simply check for conditions and return a true or false value. So they always return a Boolean value. Let us start with the double equal to operator. As you can see, num is indeed equal to 2. So we get a Boolean value in the console. So what happens if we, let's say, pass a string into our variable, will that still return 2 or true? Will 2 still be equal to 2? Well, wait for it. And yes, 2 is still equal to 2, even though we know our 2 is a string. How is that possible? Well, there's what we call type conversion in JavaScript, or simply type conversion. So this is normally common in dynamically typed languages like JavaScript, since we do not explicitly tell our code to assign a particular data type. JavaScript does that on the fly. It does the automatic type conversion for us. It's not like C or Java, right? So this sometimes is a problem. And as I say, there's implicit type conversion and explicit. In this example, we could call this an implicit, unintended, right? You don't expect it. But let's say if we wanted indeed to get a string or convert our number to a string explicitly. So we use the toString method. So this is an explicit type conversion or type conversion. We are explicitly telling our data type to convert to a string, right? We know what we are doing. But most of the case, it's important to know that the double equals performs a type conversion. So it's always going to convert the other type data type on the left. So it's going to convert the one to the right to that data type on the left. So how do I avoid that? Well, that's why we have the strict equality or the triple equals. This one avoids type conversion and strictly looks at the data types, right? Does not do any conversion. So if we get the same console here and add that triple equals, we should be getting false, as you can see. So strict equality helps us avoid implicit type conversion. Just in case you have a huge code base, it becomes very hard to debug. So it's always important for you to use triple or strict equality and avoid double equals unless you're sure about what you're doing and you're actually using an explicit type conversion instead of an implicit. Okay, let's look at the next type, conditional operator. So the not equal to operator, just like the double equals to operator, has a type conversion. So yes, it is false. 10 is equal to 10. But what happens if we pass a string instead of a number? Do we still get false using the not equals to operator? Yes, as you see, we still get false. So how do we avoid that? Again, we just use the strict not equal to operator. Just copy this and just add an additional equals, and we should get true because string and the number are different data types, and that is false. So yes, the number string of 10 is not equal to 10. Well, they're pretty much the same. All they do is match if values. I've already written down the code, as you can see, so we're just going to comment out the console logs and see what it returns. So we already have two variables, one variable of 10, another of 20. So the first condition is 10 greater than 20? Of course, we expect false, and that's what we get in the console. It's not true. Is 10 less than 20? Expect true, right? 10 is indeed less than 20. Is 10 greater or equal to 20? That is false as well, right? Because 10 is still less than 20. So we expect false. And lastly is 10 less or equal to 20. And what do we get? We still get true. So you can change the numbers, of course. So is 30 greater than 20? True. Is 30 less than 20? False. Is 30 greater than or equal to 20? Well, that is true. So that's what the greater than or less than equal to do. Just that. All right. Next, let's look at the logical operators. So logical operators, well, as simple as they are used to determine logic between variables and values. Again, we have our simple examples here, commented out our console logs, and we will be console logging one by one to see the results in the terminal and the difference between the AND logic operator, the or and not equal. So as you can see, our variable x has 20 and our variable y has 7. So our first condition is the using the AND logical operator. So how the AND or logical operator works is that both conditions must be true for it to return true, right? If one of them is false, it will return false. Both of them have to be true for it to return true. So in this example, in our console, we have 20x, which is 20, is greater than y, 7, and y, which is 7, is less than 20. So that sounds right and it sounds true. So let's see what we get in the console. We should be getting true, as you can see. But what happens when we say 7 is greater than 20? Yeah, but we know that 20 is greater than 7. As you can see, we get false, right? Even though our left condition is right, it does not matter. Both conditions have to be true for it to return true. Let's look at the OR operator. So in our console log, we have x, which is 20, is greater than 7, or y, which is 7, is greater than 20. Well, what do you think we're going to get in the console? And we get true, right? So how the OR operator works is one of them has to be true for it to return, right? It does not work like the AND. So that's the main difference. The OR, as long as one condition is true, it will return, or it will always return true, right? So we can see that on the right condition, that 7 is greater than 20 is false, but on our left we do have 20 is greater than y, so that's true. So it returns that in the console, right? And finally, let's look at the logical not operator. Well, this one is simple. It returns a false value if the conditions don't meet. Or true or false, sorry. So we know that x is not equal to 7, or 20 is not equal to 7, and that is true. All right. There are more links in our Slack community and the description below, so you can read more about that if this is still confusing you. Let's move on our final logic operator, and that's our last operator, and that's the bitwise operators. Before we move on, I'd forgotten about the ternary operator. So ternary operator is just a shorthand of your statement. Give a condition, then the question mark always returns a true condition, right? If it passes, return this. Then the colon returns the default if the condition fails. So we expect hello 10 in the console, right? Let's say if it's 11, no way, right? We expect no way in the console. Variable name, as you can see. Great. Now let's go to the bitwise operators. So bitwise operators. Well, bitwise operators simply work with 32-bit numbers in JavaScript. So what they do, they convert numbers to 32 bits, then convert the result of the 32-bit back to numbers. And just for that, I've got a simple representation of 5 in 32-bit and 1 for us to know what it does in the background. So the first operator symbol under the bitwise operator is the ampersand or the AND operator. So what this AND operator does is set each bit to 1 if both of them have 1 in the bits. As now you see 5 in binary there's 0101 and then in 1 there's 001. So it's going to set a bit and return 1. So if we uncomment this console log, we expect 1 in the console. As you can see. Great. Now let's look at the bitwise O operator, which is just a single pipe. So this one, as all we know O, it looks for a 1 in either of the conditions, in either of the binary values it has. So it sets a byte of 1 if one of them have 2 bytes. Like if one byte has two ones in it, it will now set the 1 to that binary or to that bit. And in our example, we can see 5 has 2 ones, so that's what it sets when you run the O bitwise. So when we uncomment this, we expect to get 5 in our console log. As you can see. Great. Now let's look at the NOT or the bitwise NOT and how it works. All the NOT operator does is inverse the bit, right? So our 5, this would equal to this using the NOT. The NOT equals the NOT bitwise operator. So it inverses the bit and then returns the inverted bit. So we can comment our NOT bitwise 5, we should expect, well, what do you think we expect in the console? Get -6. If you expected 10, well, why it's not 10? It's because JavaScript uses 32-bit signed integers compared to the 4 unsigned bits binary numbers used. So that's why we don't get 10, we get -6. All right. And we have come to an end of our interesting, very short operator journey. If you want to know more, you can check in the description below. There are links about operators, bitwise, and so much more. Same in our Slack community, which is J for JavaScript, and I recommend you join it and keep learning. Next, we'll be looking at our first reference data type, and that will be arrays. Catch you in the next one. Don't forget to like and subscribe, share, comment. See you. Bye.